The average American household spent $2,400 on gasoline last year. Not because gas is expensive, not because they drive too much. 3 parts under the hood were dirty. Nobody said a word. Those 3 parts, and the products that fix them, are well known inside every repair shop in this country. The products run between $7 and $12 each. You can grab all 3 off the same shelf at AutoZone, Advance Auto, or Amazon. Shops charge between $75 and $300 per service for each one. And auto manufacturers have quietly left every single one of them out of your owner's manual maintenance schedule. Intentional omission pays better than oversight. In the next few minutes, I am going to name all 3 parts, tell you what they do and what happens when they get dirty, and walk you through the fix step by step so you never pay a shop to do it again. Close this video right now and you will spend another $600 this year on gas your engine burns for nothing. That number comes from the Bureau of Labor Statistics and AAA. It is documented, not estimated. Stay with me. Before the fixes, there is something about how your engine actually burns fuel that changes the way you think about this. Most people trying to improve their gas mileage are focused on the wrong things entirely. And I am going to show you the specific mistake that keeps those people refilling their tank just as often as before. I will also name the products that work, the ones that do not, and where to find them for under $15. One more thing to stay for. Near the end of this video, I am going to show you the order to run these 3 fixes in. The order matters more than most people realize. Do them out of sequence, and the improvement does not stick. That is the reason some drivers try one of these fixes and swear it did nothing. But first, what is happening under your hood right now, on every single drive, that is costing you money? Your car's engine is essentially an air pump. Every time a piston moves down in a cylinder, it pulls in a mixture of air and fuel. That mixture ignites. The explosion pushes the piston back, turns the crankshaft, and moves the car forward. That is the whole system. Your engine does not decide on its own how much fuel to inject. A computer called the ECM, the engine control module, makes that call thousands of times per minute based on sensor data. Think of the engine control module as a chef following a ratio. For every 14.7 parts of air, 1 part fuel. That ratio, 14.7 to 1, is the stoichiometric ratio. It is the target for complete, efficient combustion. Every drop of fuel gets burned. That recipe only works if the sensors feeding data to the computer are accurate. The moment a sensor starts giving the engine control module wrong information, the fuel-air ratio slips. Either too much fuel gets injected, which mechanics call running rich, or too little, which is running lean. Running rich is the expensive one. When the engine runs rich, it injects more fuel than it can burn. That unburned fuel goes out the exhaust. You paid for it. The engine never used it. The 3 parts I am about to show you are the 3 most common causes of this problem on every make, every model, and every vehicle built after 1981. The number that should bother you. The Department of Energy and the Environmental Protection Agency, the 2 agencies that run fueleconomy.gov, documented that repairing a faulty oxygen sensor can improve fuel economy by as much as 40%. The average American household burns $2,400 worth of gas a year per the Bureau of Labor Statistics. 40% of that is $960, close to $1,000 a year. One sensor, $25 at AutoZone. Each of the 3 parts, what they do, what happens when they fail, and the exact fix, takes under an hour of your time. Go back to 1981. That is the year the EPA mandated oxygen sensors on every new passenger vehicle sold in the country. Before that, carbureted engines ran on a fixed fuel mixture set mechanically with no feedback loop. Inefficient by design, but at least you got what the carb was tuned to deliver. After 1981, the oxygen sensor changed things. The engine could adjust its fuel mixture in real time. thousands of times per minute. Fuel economy improved. Emissions dropped. The technology was considered a breakthrough. By the 1990s, manufacturers had worked out a pattern. Comprehensive maintenance schedules meant drivers spent less time in the service department. Less time in the service department meant less revenue, so the schedules got shorter. Your owner's manual today tells you to change your oil, rotate your tires, and replace your air filter around 30,000 miles. Maybe check your spark plugs. It will not say to clean your throttle body. It will not say to inspect and clean your mass airflow sensor. And the oxygen sensor guidance is vague enough that most drivers never act on it until a check engine light forces the issue. A shop charges between $75 and $300 for a throttle body cleaning that takes 15 minutes and a $10 can of spray. At $60 to $90 an hour for labor, it is one of the higher margin services in the industry. The less you know, the more they make. Quick one while we are here, drop your car's year in the comments. I want to see how many people watching this are driving vehicles that have never had any of these 3 services done. I read every comment on this channel. 3 fixes. Starting with the one the EPA says can recover up to 40% of lost fuel economy. Your vehicle has at least 2 oxygen sensors, possibly 4 depending on engine configuration. The upstream sensor, mounted before the catalytic converter, controls your fuel mixture in real time. When it starts failing, the engine runs rich and burns excess fuel on every drive. Most people do not know that oxygen sensor failure is gradual. There is no sudden moment. The sensor's platinum tip gets coated in carbon deposits, silica contamination, and oil burn-off residue over tens of thousands of miles. Its response time slows. The computer starts receiving readings a fraction of a second behind reality. That lag swings the mixture rich. Not dramatically. Not enough to trip a check engine light right away. Just enough to cost you money every mile. Most manufacturers call for oxygen sensor replacement around 90 to 120,000 miles. But degradation starts well before that, and most vehicles on American roads are being pushed past that mark without a replacement. Write this down. If your vehicle has more than 80,000 miles on it, and you have never replaced the upstream oxygen sensor, you are almost certainly losing fuel economy. Not possibly. Almost certainly. The fix. Go to AutoZone, Napa, O'Reilly, or Amazon, and search for an upstream oxygen sensor for your specific year, make, and model. Stick with Bosch, Denso, or NGK. Those 3 brands supply the original equipment to the manufacturers. You are buying the same part the factory used for $20 to $50 instead of the $150 to $300. A dealer will charge for the part and labor combined. You will need one tool you probably do not own: an oxygen sensor socket. It looks like a standard deep socket with a slot cut down the side for the wire. $8 to $15. Pick one up when you buy the sensor. The job: let the exhaust cool completely if you have driven recently. The upstream sensor is threaded into the exhaust manifold or the pipe just before the catalytic converter. It looks like a spark plug with a wire coming out of it. Unplug the wire connector. Use the sensor socket and a breaker bar. These come on tight from heat cycling. Unthread it counterclockwise. Thread the new one clockwise. Torque it snug without over-tightening, and plug in the connector. Total time: 30 to 90 minutes depending on access. Total cost: $30 to $65 including the socket. A dealer doing the same job: $150 to $300. If the oxygen sensor monitors exhaust, the mass airflow sensor, called the MAF, monitors air intake. It sits in the intake duct between your air filter box and your throttle body. It measures the volume and density of air entering the engine in real time and sends that data to the engine control module. When the MAF is clean, the engine knows exactly how much air it is working with and injects exactly the right amount of fuel to match. When it gets dirty, the measurement goes wrong. The MAF uses an extremely fine platinum wire filament, sometimes two of them, heated to a precise temperature. The sensor calculates airflow by measuring how fast the passing air tries to cool that wire. The relationship between airflow and wire temperature is how the computer reads volume. That wire is exposed to everything coming through the intake. Over time, oil vapor from the crankcase ventilation system coats the filament. Dust sticks to the film. The layer builds slowly until the filament's sensitivity is gone. When the MAF reads low, telling the computer there is less air than there actually is, the computer injects less fuel. The mixture leans out, misfires, hesitation, rough idle. When it reads high, the computer floods the cylinders. That fuel does not burn. It goes out the tailpipe. You paid for it at the pump. SE certified technicians have documented cases where a dirty MAF dropped a vehicle from 32 miles per gallon to 24, 8 miles per gallon, from a sensor that costs $8 to clean. If you search something like how to improve gas mileage, or why is my car burning more gas than normal, the MAF sensor is one of the most common and cheapest answers. Most people never hear about it. The fix: one product, a can of mass airflow sensor cleaner. Do not use brake cleaner, carburetor cleaner, or compressed air. Only use a cleaner labeled specifically for MAF sensors. CRC MAF sensor cleaner and WD-40 Specialist Electrical Contact Cleaner are both solid. $8 to $12 at AutoZone, Napa, Walmart, or Amazon. The reason other cleaners cause damage: the MAF filament wire is extraordinarily delicate. Brake cleaner residue can coat the wire and make things worse. Compressed air can snap it. Wrong product means a new sensor, not a cleaning. The job: disconnect the intake duct from the MAF housing, usually 2 clamps and an electrical connector. Remove the sensor. You will see the sensing element inside, the fine wire or film sitting in the center of the bore. Hold the can 10 to 12 inches away. Spray 10 to 15 short bursts. Let it air dry completely, a minimum of 10 minutes. 20 is better. Do not touch the wire. Do not wipe it. Reinstall and reconnect. That is the entire job. 15 minutes, $8 to $12. A shop will charge a diagnostic fee of $75 to $150 to plug in a scanner and then quote you a replacement sensor at $200 to $400 plus labor. When a cleaning would have fixed it in 15 minutes for the cost of lunch. Put these numbers side by side. MAF sensor cleaning, shop price, $120 to $300. Your cost after watching this, $8 to $12 in 15 minutes. Throttle body cleaning, which I am about to cover, shop price, $75 to $300. Your cost, $7 to $12 in 30 minutes. Oxygen sensor replacement, shop price, $150 to $300. Your cost, $30 to $65, including the socket you will use again. All 3 at a shop, potentially $750. The same 3 jobs for yourself, under $90 total. That gap does not exist because the shop is doing something you cannot. It exists because they are counting on you not knowing what you just learned. The throttle body is the gateway between the air intake and the engine. Press the accelerator and the throttle body opens. Release it, it closes. Every molecule of air your engine breathes passes through this single component past a circular valve called the throttle plate, on its way to the cylinders. Over tens of thousands of miles, that plate gets coated. The positive crankcase ventilation system, which routes crankcase exhaust gases back into the intake to be reburned rather than vented to the atmosphere, is an Environmental Protection Agency requirement going back to the 1960s. It is necessary. But those gases carry oil vapor, and that oil vapor deposits on the throttle body walls and the plate itself. The deposits harden into a dark, sticky carbon film. The plate cannot open and close cleanly. At idle, when the throttle is barely cracked, even a thin layer of buildup dramatically cuts airflow because the opening is tiny to begin with. The engine control module tries to compensate. It cannot fully. Idle goes rough. Throttle response slows. Fuel economy drops because the computer is fighting a dirty plate and losing. Vehicles with direct fuel injection, including most modern Ford F-150s, Toyota Camrys, Honda Accords, and Chevrolet Silverados, built after 2012, pick up this problem faster than older port injection engines. In a port injection engine, fuel spray washed the back of the throttle body on every combustion cycle. In direct injection, there is no fuel spray in the intake, so nothing cleans the plate. Deposits build faster. Automotive Service Association data showed that roughly 65% of vehicles presenting with idle quality and fuel economy complaints improved after throttle body cleaning, before any other repairs were done. Almost 2/3 of those complaints were resolved with a $10 can of spray. This is the part most people get wrong. They try the mass airflow sensor cleaner, and the rough idle does not go away. So they decided the mass airflow sensor was not the problem. But the actual problem was the throttle body, and they never touched it. That is why the order matters. More on that in a few minutes. The fix: throttle body cleaner specifically, not a carburetor cleaner. Some formulations in carb cleaner are too aggressive for throttle body sensors and coatings. CRC throttle body and air intake cleaner, Berryman. B12 Chem Tool or Gum Out Fuel System Cleaner. All under $10 at any auto parts store. The job: locate the throttle body, the round component connected to the large air intake duct directly behind the air filter box on most vehicles. Loosen the hose clamps, usually with a flathead or a 7mm socket. Pull the duct back. You will see the throttle plate inside. Engine off and cool. Spray the cleaner into the bore, directly onto the plate and walls. Use a clean rag or soft brush to wipe the loosened deposits. Spray again. Wipe again. Repeat until the interior is clean, bare metal is visible, and there is no brown or black residue. Reconnect the intake duct and tighten the clamps. One note: after cleaning, most vehicles with electronic throttle control, which is most vehicles built after 2005, need to relearn the throttle position. The procedure varies by make and model. For most, it is turning the ignition to on without starting the engine, waiting 30 seconds, starting it, and letting it idle 2 to 3 minutes without touching the gas pedal. Search your year, make, model, and throttle body relearn procedure on your vehicle's service form. 5 minutes, free. Total job time, 30 to 60 minutes. Total cost, $7 to $12. Shop cost for the same service, $75 to $300. For anyone watching who is skeptical, good. There is a lot of bad automotive advice on the internet, and you should want to source it. So here is exactly where these numbers come from. The 40% fuel economy improvement figure for a faulty oxygen sensor comes directly from fueleconomy.gov, the joint site operated by the Department of Energy and the EPA. That figure has been in their published documentation since at least the early 2000s. It is a federal finding, not a marketing claim. The $2,400 annual gas spend figure comes from the Bureau of Labor Statistics Consumer Expenditure Survey for 2024. BLS surveys over 30,000 American households every year. Gas spending is its own line item. AAA's 2025 Your Driving. A cost study puts the total annual cost of owning and operating a new vehicle at $11,577. AAA has published this study every year since 1950. At current July 2026 gas prices, which AAA is tracking at $4 per gallon nationally, the fuel portion of that number is trending up. The Motley Fool and Jalopnik have both independently verified, using AAA and BLS data, that at $4 per gallon, the average household is spending closer to $2,500 a year on gasoline. What that means in practice: if your engine is running 15% rich, a conservative figure for a degraded oxygen sensor, you are burning 15 cents of every dollar you spend at the pump for no forward motion. On $2,500 of gas, that is $375 a year going out the exhaust. If a throttle body restriction is causing a 20% efficiency drop, per Automotive Service Association documentation, you are losing $500 a year. Those figures are cumulative. The oxygen sensor, the MAF, and the throttle body degrade on the same timeline from the same sources of contamination. When all three are degraded at once, the combined fuel waste can easily run $600 to $900 a year. The fix for all three combined costs under $90 and under 2 hours. One direct question, and I want you to answer in the comments because it shapes what I cover next. What state do you drive in? Gas prices vary dramatically right now. California drivers are paying around $4.50 per gallon. Oklahoma drivers are paying around $2.34 per gallon. The math on what you are losing to these three parts changes based on where you fill up. Drop your state below. I read every one. Earlier I said the order matters. Here is why. The throttle body, the MAF sensor, and the air filter are all in the same airstream. In that sequence from engine to atmosphere, air enters through the filter, passes the MAF sensor, then passes through the throttle body into the engine. If you clean the MAF sensor first and start driving, dirty air from a contaminated throttle body passes back over the freshly cleaned MAF sensor during deceleration and idle. PCV vapors from a dirty throttle bore can recontaminate the MAF sensor in as little as a few hundred miles. Your cleaning did not last because you cleaned in the wrong direction. Clean the throttle body first, then clean the MAF sensor. The oxygen sensor is independent of this sequence and can be done at any point. But for the other two, throttle body first, then MAF. After that, clear any stored codes with an OBD2 scanner if you have one, then drive a full tank before judging how much is improved. That sequence is what makes this work long term, rather than giving you a week of gains before things slide back. Throttle body, MAF. Oxygen sensor, if the mileage warrants it. Write that down. The fuel economy hit is only the first problem. It is also the cheapest one. Start with the oxygen sensor cascade. When the upstream oxygen sensor degrades slowly, the engine runs rich for months before a check engine light shows up. During that stretch, excess unburned fuel is entering the catalytic converter. The catalytic converter operates between 800 and 1600 degrees Fahrenheit. It uses precious metals, platinum, palladium, and rhodium to convert unburned hydrocarbons into carbon dioxide and water. When excess raw fuel enters from a rich running engine, that fuel ignites inside the converter. Internal temperature spikes far beyond design limits. The precious metal substrate melts and fractures. A failed catalytic converter costs $800 to $2,500 depending on the vehicle. On a Toyota Camry, one of the top-selling vehicles in the country, a front converter replacement runs $1,200 to $1,800 at a dealership. Parts alone are $600 to $1,000. That failure came from a sensor that costs $25 and takes an hour to swap. RepairPal and Edmunds both document catalytic converter failure following extended oxygen sensor neglect as one of the most common and most preventable expensive repairs in the industry. The throttle body cascade runs the same way. A severely contaminated throttle body does not just hurt fuel economy. As deposits harden and the restriction gets worse, two more problems develop. First, the idle becomes unpredictable. The ECM compensates by opening the idle air control valve further and further. Eventually, the deposits cause the plate to stick. The engine stalls at stoplights while parking in traffic. That is a safety problem, not just an inconvenience. Second, a sticking throttle plate sends erratic signals to the throttle position sensor, the TPS, which tells the computer where the plate is at all times. Conflicting signals from a plate that is sticking and releasing unpredictably can trigger a cascade of error codes and put the ECM into a protective mode that limits performance and efficiency further. TPS replacement costs $100 to $250. ECM recalibration at a dealer costs another $100 to $200 in labor, all from skipping a $10 can of throttle body cleaner. The MAF sensor, left dirty long enough, causes the engine to calculate incorrect long-term fuel trims. These are the ongoing adjustments the ECM makes to try to correct for persistent sensor error. And those bad fuel trims can persist even after the MAF sensor is cleaned, because the computer has learned wrong. After cleaning the MAF sensor, you need to reset the ECM's fuel trim data so it can relearn accurately. A basic OBD2 scanner does this. Clear the long-term fuel trim data. Drive normally for one full tank. The engine control module relearns with accurate sensor data and the fuel economy. Recovery is complete. Skip that reset, and the engine control module continues compensating based on dirty sensor data for weeks. You will not see the full improvement until it corrects itself naturally, which takes longer than it should. That is the full chain. A $25 sensor becoming a $1,200 converter. A $10 spray can become a $250 sensor and a dealer recalibration bill. Every one of those outcomes was preventable. The math, one more time, so you have it in your head at the pump. The Bureau of Labor Statistics documented the average American household spent $2,400 on gasoline in 2024. At current July 2026 prices, $4 per gallon per the American Automobile Association. That number is trending toward $2,500 this year. If all three components are degraded, the combined fuel waste based on documented efficiency losses is conservatively 15 to 30% of total fuel burned. 15% of $2,500 is $375. 30% of $2,500 is $750. That is money you are buying at the gas station and burning for zero forward motion. Total cost to fix all three yourself, $30 for the throttle body and MAF cleaners combined, and $35 to $65 for an oxygen sensor and socket if your mileage warrants it. Call it $90 all in. Over 5 years, with these three components maintained, you are looking at $1,500 to $3,000 in recovered fuel economy, against $90 in materials. Take a screenshot of that. Or, save this video. The next time a service advisor slides an estimate across the counter, you will want those numbers in front of you. Every week on this channel, I pull one of these buried fixes out of the archives. The things your owner's manual skips. The things your mechanic profits from you not knowing. The things that have been sitting on the shelf at your local auto parts store for 30 years. Next video. There is a small rubber valve under your hood that costs $4. When it fails, and it fails on 1 in 3 vehicles over 80,000 miles, it does not trip a check engine light. It makes no noise, nothing dramatic. It quietly begins pumping oil vapor into your intake manifold, coating everything downstream, destroying your fuel economy, and setting up a $500 to $800 cleaning bill at a shop. $4, 1 in 3 vehicles, no warning, see you there.